Hello everyone, welcome to the correlation section. If you haven't watched the descriptive statistics session in the introduction to SPSS session, I recommend you to first go through that two sections and then we can do this correlation section. In this section, we're going to talk about what is correlation analysis and how to practice it in SPSS. So correlations are different from descriptive statistics. It's a kind of inferential statistics that tests the relationship between two continuous variables. Correlation can show whether and how strongly variables are related to each other. So for example, your height and weight are probably related to each other. If you're taller, you might be heavier. And if you're shorter, you might be lighter. And one important thing to remember about correlation is that the correlation does not equal causation. As you can see from this picture, for a correlation, there may be that people who breathe will die. So there is a relationship, there is a correlation between birth and death. However, this does not mean that birth causes death. On the other hand, for causation, people who don't breathe will die, and that is definitely a causation. So a causation definitely means a correlation, but correlation is not necessarily causation. So for this class, we're gonna using Pearson's R linear correlation analysis because there are tons of different kinds of correlations, but for this class, just gonna use Pearson's R. It's a kind of measure of the linear dependence between two continuous variables, x and y. So for linear correlation, there are different kinds of correlations, as you can see from the scatter plots. For your left-hand side, that's a positive correlation, which means that when x increases, the y will also increases. And your right-hand side is a negative correlation, which means that when the x increase, the y will actually decrease. An example for positive correlation, as we just talked about, is the height and weight. So, generally speaking, if you're taller, you may be heavier. And a potential negative correlation may be the relationship between exercising and weight. If you're exercising more, you might be lighter. That's my assumption. I'm not sure if there is actually a negative correlation, but that's what negative correlation means. And there is another kind of situation, as you can see in this scatter plot, that there is no correlation. You cannot find a line there. To detect the strength of the correlation, we're gonna use R value. So the R value, or the effect size of the correlation, range from -1 to 1. So if it's a positive correlation, it will range from 0 to 1. And if it's a negative correlation, that will be from -1 to 0. So the closer the correlation is to 1, the stronger it is. Both positive or negative 9.8 will be a strong correlation. The positive or negative sign is just indicate the direction of the correlation. So the rule of thumb for R value is that if your R is greater than 0.5, that will be a strong correlation. If your R is between 0.3 to 0.5, that's medium. And if it's less than 0.3, that will be a weak correlation. So there might be, in many cases, there are strong correlations. For example, the last time I find that the correlation between depression and anxiety in my research for my participants are 0.6. So that's a strong correlation between depression and anxiety, and that totally makes sense. However, in real life, we usually find just medium or weak correlations in our research. And medium or weak correlation does not represent that this correlation is not significant, does not represent that this correlation is not good. It's just that the correlation between the two factors are weak. In addition to effect size, in addition to R values we have for correlation analysis, another significant indices for to evaluate the correlation is the p-value. So p-value indicates whether or not your results are statistically significant, whether or not your results were found by chance. So remember that R value indicates the strength of the relationship. Now, even if you find a 0.99 strength, a 0.99 R value, if your p-value is above the critical line, then we still say that there is no relationship between the two variables. So remember that we cannot prove the research hypothesis is true. So we try to demonstrate that the alternative hypothesis is more plausible than the null hypothesis. So one critical line we use for p-value is 0.05. So if your p-value or the significance value, that's the nickname for p-values in SPSS. So if your p-value is less than 0.05, there is only a 5% chance that the null hypothesis is true. So we can say it boldly that there is a significant relationship between your variables. But if your p-value is above 0.05, for example, it's 0.67, well, that's a high p-value. And that means the patterns of the results will be found 67% of the time. It's just a by chance thing, probably, if this will happen 67% of the time. So we cannot say that there is a relationship between the two variables. So in addition to 0.05, there is another critical line, which is more strict critical line for p-value, that is 0.01, which means the patterns of results will only be found 1% of time. So if your p-value is less than 0.01, which is good, which means that it is unlikely that your results will be due to chance. So after I introduce you basic concepts of correlations, let's practice it in SPSS. Welcome. So again, we're still using the intro survey of the Psych Foundation class, and I am choosing two continuous variables to practice the correlation analysis, because remember, correlations can only be practiced between two continuous variables. I decide to choose these two variables. I want to know whether there is a relationship between your love for Pepsi and your love for Coke. So let's do analyze, correlate, bivariate. Same as we did before, we switch it to display variable names. We look for question 16, 2 and 3. So 2 and 3. We want to do Pearson's correlation, which is good. This is Pearson's. We want to do two-tailed test of significance options. We want to see the means and standard deviations. We can have it. And okay. So as you can see here, the mean for love of Pepsi is 30, and the love for Coke is 55. Wow, so you guys like Coke. You don't like Pepsi. And the standard deviation is, I would say, similar, 24 versus 30, considering the range is big. It's 0 to 90, right? And let's say the correlation. The Pearson's correlation between Pepsi and Pepsi is definitely 1, no, because that's the same variable. And the correlation between Pepsi and Coke is 0.31. That would be a medium correlation. However, as we can see here, it's not significant. P equals 0.15. 0.15. So it's not significant. So there is no relationship between your love of Pepsi and your love of Coke. So we're gonna look for something that has relationship. Hello, everyone. I just do some exploration of the data, try to find some strong not strong correlation, try to find some statistical significant correlation, and guess what I found? Here is what I did. Yes, you can have a lot of different continuous variables enter into the same correlation analysis, just like this. Analyze, correlate, bivariate, a lot of things you want, and that will. And for the final table, you're gonna have like each against each other, and we do find a significant correlation here. That is whether you like Pepsi and whether you like Beyonce. So those who like Pepsi hate Beyonce. That's what this is telling us, because it's a negative 0.51 relationship, R value, and the significance value here is 0.016. So it's below 0.05. And that's why we have this 1 star here. And you can see here, the correlation is significant at the 0.05 level, 1 star. Correlation is significant at the 0.01 level, that will be 2 stars.